Assalamualaikum warahmatullahi wabarakatuh. My name is Mirza bin KAMARUDIN ELIAS, and this is a presentation for final year project 1, and the title is Surface Texture Analysis, Feature, Definition and Recognition, and my supervisor is Dr. FAUZI bin ISMAIL. For introduction, the surface texture analysis improves product performance and functionality by evaluating the functional topography. Several microfabrication procedures can yield to complicated 3D structures that are challenging to measure. For example, the topography of microelectromechanical system, which the simulated data that will be developed for this project algorithm testing. Even though numerous segmentation techniques for surface feature have been provided in prior research and can aid in detecting surface edges. Surface texture definition recognition can be done through the segmentation process. It is anticipated that as time passes, surface topography assessment will become more accurate and dependable in its application to the solution of fundamental engineering problem. The feature segmentation approach is one of the major strategies that need to be taken into consideration when examining the surface topography. This is because it can extract the region of interest and segment them into meaningful pieces that have equal features and properties. There is various ways to do the segmentation process through algorithm that already exist, such as water segmentation and sorbet operator. This study is to develop an algorithm that combine the watershed segmentation and sorbet operator algorithm into one, and the tool for this project is MATLAB. In literature review, students investigate previous study that handling recognition process, which is watershed segmentation and sorbet operator. To handle this project, students need to understand the method that can be used to do the recognition process. Due to the ease with which it can be calculated, the sorbet gradient function is one of the edge-based method that is frequently taken into consideration. The sorbet operator algorithm make use of two kernels. One identify the horizontal edges and the other identify the vertical edges. By applying these two kernels to the surface topography texture in various points, it is possible to calculate and compute the gradient along the x and y axis. Figure below demonstrates sorbet operator applied on a simulated surface topography. The result that was obtained is in some way unsatisfactory. This is because it can be observed that this operator is only able to construct a gradient function of a surface and signal the edge without being able to indicate the precise location. The other method that can be used for recognition process is water segmentation. Watershed segmentation divide the surface topography into hills or dales depending on the gradient estimated. The surface segmentation create a non-intersecting zone. Image processing use segmentation technique extensively. Image segmentation is used to determine object boundaries. It's also the first stage before feature identification. The first thing that has to be done in order to do water segmentation, it is to decide what kind of textural characteristic will be utilized for the analysis. Following that, topographic elements such as valley and hills are chosen. Watershed-based surface segmentation divide topography into hills, that is, areas where most uphill paths lead to one peak, and dales. Dales is area where most downhill paths lead to one peak. Watershed segmentation drawback is over segmentation. Figure below shows a result of watershed segmentation mapped on a surface topography, and it can be seen that the boundaries are far from the features. As for the watershed segmentation combined with sorbet operator, the figure shows the watershed line maps applied on the sorbet gradient function, then the method was transferred to the surface topography. The watershed line follows the slope of the surface topography. The white lines border are more visible and closer to the feature range. This proves that watershed segmentation and sorbet operator are suitable for surface recognition, but there is still no algorithm that combine these two methods. Thus, an algorithm combining these two methods need to be developed. For the problem statement, surface texture analysis had been done a long time ago. Many methods has been used to recognize the segment and edge, such as watershed segmentation and sorbet operator, to analyze the surface texture topography. But the algorithm exists, have to be used separately and consume a lot of time. So, this project main objective is to develop an algorithm that combine watershed segmentation and sorbet operator into one to be applied in surface texture analysis to recognize the surface feature. Electromechanical system simulated data had been chosen as a sample for this project. The objective of this project first is to prepare the sample data. The data of surface texture using digital imaging and data of simulated topography of the microelectromechanical system or MEMS. The simulated data will be created using Excel, SUME, and MATLAB. And the next objective is to develop the algorithm to define and recognize the surface feature. This is using the existing method that can be used to define and recognize the feature of the surface, such as watershed segmentation and sorbet operator, and compile it in to develop a new algorithm. And lastly, the objective is to analyze and evaluate the algorithm by comparing the result obtained with the existing method in order to evaluate the efficiency of the algorithm created. A scope and limitation of the project. This study is about the application of surface methodology only for MEMS component. Due to limitation of instrument, the samples are created using digital imaging and data of a simulated topography of MEMS component. The simulated data will be analyzed using MATLAB software. On the simulated data surface, the analysis will be carried out using watershed segmentation and the sorbet operator. During the investigation, the number of study parameters will be decided. The analysis of the result will then be used to develop a conclusion. For methodology, the figure A shows the data processing that will be covered by the algorithm, which is segmentation, isolation, and leveling. This project only covers on segmentation algorithm. The method involved is initial research, data preparation, algorithm development and testing, and evaluating the algorithm developed as shown in figure B. Initial research. This involved conducting a literature review to discover earlier studies that had been carried out on the recognition method, as well as compiling the most significant finding and algorithm that has been discovered as a result of the previous study. For data preparation, as part of the process of preparing the data, simulated surface topography will be developed. The analysis of the algorithm will make use of the data that was developed. The surface texture data used in this project is MEMS component. So in this process, the simulated surface topography developed using existing tool that is Excel, SUME, and MATLAB. For algorithm development, the software MATLAB will serve as the instrument for the process of algorithm development. This procedure involves gathering and combining existing algorithms such as watershed segmentation and sorbet operator, as well as executing the development algorithm based on the finding of the research. Next is analyze the data obtained. After the process of segmentation and edge detection has been completed, the result will be compared to the algorithm that already exists, as well as any other approach that were discussed in the literature review. If the result is acceptable, the data will be handed for the acceleration process. If not, the algorithm developed need to be fixed or improved. For the expected result, the figure shows the preliminary result, that is the data of simulated surface topography of MEMS components that are being created for this project. The data was created using Excel, SUMED, and MATLAB. This developed simulated data will go through further algorithm development testing to achieve the other objectives of the project. From the figure, the blue area is the flat surface of the data, while the yellow area represents the uneven surface that need to be tested through the algorithm that will be developed by combining the existing algorithm. With the algorithm that is combined, it is expected that the edge and boundary that exists on the surface can be defined and recognized. That's all from me. Thank you.